our presentation on laser cutting and welding for our IME 300 manufacturing class. So we'll start out with a brief history of both welding and laser cutting. So welding was actually created in about 3000 BC, where the first type of welding was forge welding, where they heat up the two pieces of metal until they're hot enough where they can smack them together and they become one. And you can see a picture down here of that process. In 1888 AD, they created what we now call stick welding, where you have an electrode and it's connected to a welder and completes the circuit, melting the electrode and forming the two pieces together. In the 1940s, MIG and TIG welding were created. These three are what I think would be considered the big three types of welding nowadays. In the 21st century and recently, we have started using laser beam and robotics welding, which we'll see more of later in this presentation. Laser cutting is a much more recent invention. In 1917, Einstein had his theory of stimulated emission of radiation, and then in 1959, Gordon Gould created the laser theory, which we actually talked about in class a couple days ago. So in 1660, using that theory, the first laser was actually created in California. And then in 1969, so shortly after the laser was first created, they turned it into a laser cutter and were actually able to use it commercially. And today, it's used very commonly, especially in the automotive industry. Moving on, there's a lot of different things produced with both of these processes. So for welding, it's mostly used on metals and thermoplastics. In the automotive industry, for bridges and infrastructure, and for oil and gas pipelines. See down here, this is actually some plastic welding, which is probably not something we think about quite as much when you think of welding, but it is also done. And then some oil lines that are being welded, which is a big job. It always needs more people on. Over here for laser cutting, all sorts of materials can be laser cut: metals, plastics, wood, many textiles, automotive parts, electronic components, and aerospace components. Up here, we actually have a video of a PCB board being laser cut. So this might be something that's less common for us to think about, but still something using the same technology that we're fairly familiar with. So a few environmental considerations for each of these. Welding is near net shape production, meaning there is very little waste, which is a positive thing, but there are a few post-processing steps sometimes. Some potential problems are air quality and gas emissions, energy consumption, and UV radiation, which can cause health issues for the person doing the welding. Laser cutting is also near net shape production. Same thing, little waste, but some post-processing steps, and has similar problems with air quality and gas emissions, energy consumption, and a lot more material waste with laser cutting as opposed to welding.
Laser cutting is technology that's used to vaporize materials. It's very up and coming. It's being utilized in a lot of CNC applications. It's typically used for industrial manufacturing in that sense of things. However, it's also used just about everywhere, whether that be in schools, hobbyists, and many other applications. For welding, PPE is one of the most important things. You have your hood, which will reduce your radiation to your eyes. They often recommend using a respirator as well as protective clothing so you don't burn yourself. The three main types of welding are your MIG, which is your metal under gas welding, which uses an electrode to join two pieces of metal together. Your TIG, which is your tungsten insert gas welding, which utilizes a tungsten electrode, on your stick welding, which is the shielded metal arc, and that's just an electrode covered in flux. These different types of welding require different machinery.
It's a smooth, steady movement along there, and you'll want to maintain a consistent travel speed, or the speed that you're moving along your plate, and that'll give you a nice.
So these are the different styles of welding. So you can do like where you chase the weld and you pull the puddle across, or you can just go a straight weld.
Or you can do a technique that's called a whip and pause technique, where you'll move the electrode forward about 1/8 of an inch and then back into the puddle, and forward about 1/8 of an inch and back into the puddle. And so those are the different movements that you can do as you weld. So I'll just show you real quick how each of these different rods run. So first I'm going to run some 7018, and I'm running this at 115 amps, 1/8 inch 7018 on a DC inverter machine, and you can see it runs nice and smooth. And after the weld is run, I'll use that new chipping hammer that I picked up, and the slag just scrapes off nice and easy. Next I'm going to run the 6011, and I'll start out by running a stringer bead with it. And you can see the 6011 is typically a rod that tends to penetrate and cut really deep and has an aggressive arc, right? So you can see some spatter coming off of here running a stringer bead. So I'll move to the whip and pause technique I talked about before, where I'm moving in and out, forward and back in the puddle. And as I do that, it gives a little bit of time for the weld to cool, and I make a series of ripples like that. And that's running pretty well here. Now cleaning the slag off, 6011 is a little more challenging. It's a little more crusty and flaky. It takes some brushing, and it's a smooth, steady movement along there, and you'll want to maintain a consistent travel speed, or the speed that you're moving along your plate, and that'll give you a nice smooth bead. Now if you're running the 6011,
And now for the different applications of welding, you can go with assembling things. So it's often products ranging from automobiles to airplanes, different machinery. They use it in shipbuilding, building the metal hulls and framework. Pipeline construction is one of the huge applications for transporting oil across country. And it's even used in the metallurgy of industrial buildings.
So we did a small case study on some different applications for lasers and welding. We found EB Industries, which builds a very interesting 5-axis machine that does welding and cutting in the same machine. So we looked at the Triumph TrueDisc 4001 laser. These are mainly used in the automotive industry and some in aerospace. They're mainly used in the auto body industry because they can be used on small or large unibody applications that have more than one machining welding on one part at a time. So some of the pros and cons of this machine is the pros, this thing is super accurate. It can hold 6/10,000ths of an inch in true position, which is insane when it comes to a 5-axis machine. Most of the mills and stuff that I work with in my co-op cannot do that. We're lucky to hold 2/1000ths. So that was a big deal to me on this machine. It's also very, very fast. At 3,300 inches per minute, that is a super fast machine. That really increases your efficiency in your work area. Has a pretty large work area of about 6 feet, and it is a dual process machine, as I said. So it can do laser cutting and welding on the same part in the same process. The only cons that these machines have now are they are extremely expensive, costing upwards of like $10 million for one machine. And they also have a large operation and maintenance cost in terms of the consumables that they use and the parts for them, the lenses and the nozzles and everything are very expensive. So they had some design challenges with this machine. With the company they initially designed the machine for. They were trying to weld multiple parts, precision parts, or cut them and weld them, and they had to do individual precision components that had to hold 5/10 or 6/10 of accuracy on the parts, and then put them together. So they found their best solutions to this were using proper welding techniques with the laser and using the proper heat, which took a long time to develop. So we added this short little video of seeing the machine work in welding and in laser cutting. So in the first part of this video, you can just see how fast the machine moves. On this stamped steel part, it can cut off the excess very quickly. In this welding video, you can see how fast parts can be welded. No human can keep up with this machine.
Okay, and just to finish with this presentation, I'm going to talk about some of the pros and cons of both of these technologies. Starting with the laser cutting, the main advantages are, for example, the high accuracy of the cut, the high cutting speed, although the speed depends on the thickness that you want to cut. Also, it's an automatable process. It's really easy to make it automatable. And it's a clean process because you don't have lots of wasted material. Also, one of the main advantages of this process is that you don't need a tool, so we are not going to spend lots of money on new tools and spare parts in this case. And also, one of the main advantages is the high variety of materials that you can work with. Metal, plastic, wood, plastics, whatever you want to cut with it. Also, the disadvantages are probably that you can cut more than 25 millimeters. It's really difficult to cut more than that. If you want to only make a drill, for example, maybe you can reach over 50 millimeters deep, but not more than that. This process produces toxic smokes that could be dangerous for the operator. Also, it's a high energy demand process. It makes this process a little bit expensive. There are lots of spare parts. We are talking about CO2 laser, it's really common that we have to change a lot of pieces in a short period of time. And also there's a high risk for the operator to get burned or injured. Moving to the welding technology, we have these advantages. By welding we can build strong joints. Sometimes these joints are stronger than the material that we have before the process. Also the high resistance of the joints, well, it's almost the same. It's a fast process and it's used in a huge variety of industries because it's really well, I don't know how to say it. Never mind. It's also a cheap process, and yeah, those are the main advantages. And for the disadvantages of welding, we have that sometimes when you weld two parts, there are remaining forces in the material, so it's difficult to make the parts be in the position that you want them to be. Sometimes they move, so it's a difficult process, and you need some qualification. Not everyone can do this easy and have a good result. There's also some risks for the operator. Going blind is the biggest one if you don't use your protection eyewear. And there's a material limitation for these processes. It's, for example, much easier to weld steel than welding aluminum. And those are all the disadvantages.
So in conclusion, some of the big points we covered today is the 3 different kinds of welding: MIG, TIG, and stick welding. Both welding and laser cutting are commonly used in many industries today. We gave a lot of examples of those throughout the presentation. And as seen in the case study and talked about many other times, robotics is going to greatly influence both of these technologies. Here we have our sources, and that's all we have for you today. Thanks for watching.